Sorry I couldn't be there today. I had an appointment and they could not schedule it at any other time. But we'll do these notes through video instead. And so we're going to talk about section 6.6, which is called the remainder theorem and factor theorem. We still have section 6.7 and 6.8 to do after this. But for today, we got two different concepts we're going to talk about. So start with this one called the remainder theorem. If we just read it here, what it says is that if a polynomial p of x, so that's any kind of a trinomial or bigger, if we're going to divide it, it says, by some kind of a piece, an x minus r. Notice it says divided. That's when we did our synthetic division. So that's, you can even see in that first example, it's going to tell me to do synthetic division. Sometimes they will call that synthetic substitution instead. Same thing, same concept. They just call it substitution for some reason. But if you were to take and do synthetic division, you're going to get a remainder. And it turns out that it says the remainder is the same as P of R, whatever that means right now. So I'm going to do an example here that's this part A and part B, and hopefully by the end of it, you'll understand what they're trying to get to. So example A here says to use synthetic division to divide negative 3x squared plus 5x plus 4 by x minus 3. Remember, synthetic division, you have this little box thing in the corner, and you reverse whatever it started with. So instead of x minus 3, we're going to use a positive 3. We throw our numbers in here, our coefficients. They're all there, so it's negative 3, 5, and 4. All right, we have our remainder is going to be down in that bottom corner under the 4. We bring our negative 3 down, multiply these and get negative 9, add them, get negative 4, multiply, get negative 12, and add and get negative 8. That should be kind of review. You should know how that works. Okay, so if we're going to divide it, I guess our answer, the 4, the negative 4 right here, that does not have an x. This is an x. If there was another piece, this would be an x squared and an x to the third and an x to the fourth, and that's how you build this polynomial. But what we're doing here is we have negative 3x minus 4, and then to do our remainder, since it's negative, we'll put minus 8 on top and x minus 3 on the bottom. That's the division part. Now, as I scroll up, you'll see part B. Part B looks completely unrelated, and it says to do f of 3. That means take whatever function, whatever polynomial. We're talking about this guy. I'll underline it real quick. Oh, let me change to red. I'll underline it in red right there. That's the polynomial. In this one, it wants f of 3. It means just plug a 3 in for all those pieces, all those x's. So I'm going to have negative 3, and right here instead of the x is going to be a 3 squared, plus 5 times, instead of the x is a 3, and then plus 4. Okay, let's just work this out. 3 squared is 9. 9 times negative 3 would be negative 27, plus 15, plus 4. Negative 27 plus 15 is negative 12, and negative 12 plus 4 would be negative 8. And so what you are supposed to see by doing this is the following. Part A and part B. Notice the remainder in part A was negative 8. The answer for part B was negative 8. This is exactly what the remainder theorem is trying to say. So as I go back up to it, it says this. If you do the division, your remainder, you know how to find it in the division. That's the negative 8. It is the exact same thing as if instead of doing the division, you took this R and plugged it into P instead. And so what you would end up getting is the exact same answer. Okay? Let's try another one that's very similar to this. This one says if f of x is equal to 3x to the fourth minus 2x cubed plus 5x plus 2, find f of 4. The old way that we would do this, Algebra 1 or earlier this semester, and even last semester, we did some of these function things. We would have taken a 4 and plugged it in for everything. But what the remainder theorem is now saying I can do is do synthetic substitution or synthetic division instead. When it says f of 4, it's already been flipped for me, so I'll use the 4 in there. And let's set up our synthetic division. It has the fourth power, third power. There is no squared term, so don't forget your 0. So it goes 3, -2, 0, 5, and 2. What the remainder theorem says is whatever I get down here for the remainder is the exact same thing as doing f of 4. So this should be quick if you're good with your multiplication. The 3 comes down, multiply, you get 12. Add, you get 10. Multiply, you get 40. Add, you get 40. Multiply, you get 160. That would be 165. And okay, for the first time, I'm going to struggle here. 165 times 4. I can do it off to the side, or I can grab a calculator. It turns out that is 660. And so then you plug in the, or you add those together and you get 662. And there we go. That's my answer. You might wonder why that's important to do. Think about the other way to do this problem. It would be something like this. I would have to do 3 times 4 to the 4th minus 2 times 4 to the 3rd plus 5 times 4 and plus 2. Working my way backwards wouldn't be a problem. The 2 is fine. That's 20. 4 to the 3rd is 64 times 2 would be 128, I guess. And 4 to the 4th, I don't know that. And then I got to take it times 3. These numbers are just big. Over here, I was multiplying 4 times 3 or 4 times 10, and it was just much quicker. If you type all that into your calculator, though, you're going to get 662 just like you did. Okay, let's do it one last time. Here's your problem. If you have this f of x polynomial, it wants to find f of 3. So I'm going to do synthetic division with my 3. And then all my coefficients will be 3, -6, 1, and -11. Bring down my 3, multiply, get 9. Add, get 3, multiply, 9. Add those together, get 10. Multiply, get 30. 30 minus 11, that'd be 19, and I am that quickly done. Instead of having to take 3 to the 3rd power, then times 3, and 3 to the 2nd power times -6, and then having another 3 and a -11, it's just much quicker and much easier. And that is the remainder theorem. So next we're going to end up talking about factors and what makes them special.